Welcome back to the channel again. Let's solve another problem today. Today's problem is from LeetCode problem number 88, merge sorted arrays. So we are given two integer arrays, nums1 and nums2, sorted in non-decreasing order. So basically it's increasing. And two integers, m and n. M is the number of elements of nums1 array, and n is the number of elements of nums2 array, respectively. Now we need to merge nums1 and nums2 into a single sorted array in non-decreasing order. The final sorted array should not be returned by the function, so we should not be returning any function, any return, but instead we need to store all the elements inside the array nums1. To accommodate this, nums1 has the length of m plus n, where m elements denote elements that should be merged, and the last n elements are set to 0 and should be ignored, and nums2 has the length of n. Okay, let's understand. So we are given this input, nums1. Nums1 has, this is m elements, and nums2 has n elements. You can see nums1 has 1, 2, and 3 elements, so m is 3. And nums2 has also 3 elements, 1, 2, 3 elements, right? But nums1 has some space left, and they are filled with zeros. Basically, this number of zeros, they are equal to number of elements of nums2. Right? Because once we merge nums1 and nums2 together, all of the nums1 elements are going to occupy this, either all here or after sorting, so they will go in different place. For example, so this m, this number of zeros is equal to n, right? So right now we need to merge these two sorted array, and even after we merge, they should stay sorted, right? So basically the arrays we are merging is the first m elements, m is 3, 1, 2, 3, this, and nums2. Nums2 doesn't have any zeros. It can potentially have 0, but right now in this example we don't have 0, right? After we merge, basically 1, 2, 2, 3, 5, 6, right? One of the two is going to be replaced with this, right? Basically they're gonna exchange the place, right? So what we can do, the very first solution that we can come up with, it can be simply we merge, right? We are going to iterate this array, right? This array, let's say the first one, right? Iterate this nums2 array. Nums2 array, we will start from this nums2 array. Then all the elements we are going to add to nums1. Let's say nums1 is going to have, simply we're going to take the first element 2, right? We're going to take this first element 2, and we're going to bring right here, and this will come here, and 6 will come here. So nums1 will have 1, 2, 3, 2, 5, 6. All of the zeros, they are filled with the elements of nums2, right? Then what we can do, right now this is how many elements we have. We have, this is initially m, this is n elements, right? Total we have m plus n elements. this is the first step, right? Basically, go through this nums2 and try to just add all the elements to the from the end of the nums1. This is the first step. Basically, then the second, what we do, we sort this, right? Basically, sort this nums1. Basically, we just simply do nums1 sort, right? So you can see here we have the time complexity, right? This adding the sort usually takes we are sorting the nums1, right? Nums1 has m plus n elements. When we do any sorting, that will be m plus n log m plus n, right? So this is very expensive, right? So this is times. So this is one way to solve this problem. Basically, merge these two arrays, then sort. And there can be another approach where we can use read and write pointers. Basically, we are going to, let's say this is I'm gonna erase this. Okay, after erasing, what we'll do, so we just see nums1 is going to have 1, 2, 3, 0, 0, 0, and nums2 will have 2, 5, and 6, right? So we are going to have two pointers, and pointer 1 is we are gonna put pointer two read pointers, right? Read pointers, this is nums2, two read pointers. This is a read pointer 2. Then we're gonna put the read pointer 1 here, the very non-zero element of the nums1, right? Basically, we are gonna initialize this read pointer. The first element is m minus 1, and the read pointer 2, n minus 1, right? And the very last element of the array. Then we need to start writing from the very end of nums1, right? This nums1, we are gonna initialize a right pointer here, right pointer w. I'm gonna say w here. That w, if this is m, this is n, and this w, we need to initialize this m plus n minus 1, right? Then we need to start comparing the element in R1 and element at R2. Whichever is bigger, we'll see 6, and this element 3. Then whichever is bigger, we start writing on the very last element, right? If we just write on the very last element, it will be what? 6 will come here, right? Then after we fill this element, then we're gonna move this right pointer to the next one because this is already filled, right? And at the same time, after we write this R2, we are gonna move the R2 to the next element, right? Then we compare these two guys, whichever is big. 5 is big, right? The R2 is coming here. 5 is bigger than 3. Then we're gonna fill this one with 5. So let's say 5, right? Then this 3, this R2, we're gonna come with this one, right? We move. Whichever element we write, then we move. And this is a W2, W we moved. Now W is here, right? Now 2 and 3, we're gonna compare again because 3 did not move. It's still in the same place. So 3 and 2 we are gonna compare. Then 3 we'll just write here 3, right? Now this is the end, right? After this is the end, then we check if nums1 or nums2, any one of them have remaining elements, right? In this case, nums1 has remaining elements, so this 2 is gonna come and occupy here, right? After we just occupy, because this 2 and 2, right now this R1, after we write R1 here, then R1 will come here. So this 2 and this 2, they are equal, so we just write this 2 here, and the R2 remaining of the R2 is gonna stay here. So basically in this approach, I will show the code, so it will be much clearer in the when I show the code. So basically here the approach is we are gonna use 3 pointers, 2 read pointers. So we're gonna just read pointer 1 and read pointer 2, and W is a write pointer, right? Write means that we're gonna write here, right? So we start writing from the end of the array. So this approach, as you can see, does not have, it has the time complexity of O n plus n. This is a time complexity. And the space complexity, it's going to be O of 1, right? Because we are not taking in a space, we are simply taking the elements of nums2 and comparing with elements of nums1, and we are writing from the end of the nums1, right? So basically, space complexity is going to be O of 1. So let's see the code. Okay, so the first one here, P1, is the pointer at that we placed at the end of the nums1 array, because m is the length of nums1 array, and P2 we just put we just place at the end of the nums2 array. Then we also initialize the write index. We initialize that at the very last element of the nums array, starting from the last 0, right? m plus n minus 1. Then while write index, because we are decrementing, right? Write index. Whenever write index is greater than 0, we check if did we reach, right? Both arrays have remaining elements. Did we reach the end of any array? We make sure if P1, the pointer that we initially placed at the end of the first nums1 array, if that's non-zero, and P2 is non-zero, right? We are still iterating, traversing this two array, and we check if nums1 at pointer P is bigger than nums2 at pointer 2, then and the nums1 and the write index is the very last element, right? So we write in there that nums1, whichever is bigger, right? If nums1 at P is bigger than nums1 at P, nums2 at P2, then we just write that bigger element to the write index, starting that we are placing the larger element from the nums1, right? Then we decrement that nums1 because that's larger, right? If nums2 is bigger, then we write that write index, we write the nums2 element, then we decrement nums2 pointer, right? So if, on the other hand, if nums1 has remaining elements at the very end, if nums1 just might be, m might be larger than n, right? So if m is larger than n, still, if the nums1 has remaining elements, and it means that P1 is larger than P1 is larger than 0, then we start writing that P1 nums1 elements to the nums1, right? And we start decrementing that remaining nums1 pointer. On the other hand, if nums2 has remaining elements, then we start writing that index, that nums2 element, remaining nums2 elements, right? Then we decrement the nums2 pointer, basically. And at the very end, we need to move the either nums1 element is bigger or nums2 element is bigger. So we don't care. All we need to do at the very end of this if statements, we need to move the right index, right? We don't want to overwrite whatever we have written on the nums1 array. So we need to decrement that nums1 array here so that we can start writing on the next available place, right? So that we don't overwrite it. So that's this does it. So this is, as I said, that's O of time complexity is O of m plus n, and space complexity is O of 1. So this is it for this problem. And if you guys like this explanation with the whiteboard and the code, please comment the video and ask your questions if you have any.